So in this week's episode, we're going to look again at the ESP32 and the battery monitor that I am putting together, and we're going to walk through the NMEA2000 side, and we're also going to look at the soldering and stuff like that I had to do to set them up and to prepare them to go onto the boat. So as part of this build, I've got several boards to prepare. By prepare, I mean do a bit of soldering on, set some things like on the voltage regulator, for instance, I've got to set the voltage, and on the NMEA2000s, I've got to set the address. So I'm going to show you that as an example. I'm not going to do them all in front of you. I'm just going to show you some of them as an example. This is the voltage board, and it has a little pot in the corner here. But on the back, it basically has a way of shortcutting that and allows you to connect a 5 volt connection directly. It's difficult to see, it's very, very small. And a lot of the time I use a magnifier for this. The 5 volt one is the fourth one down. So what I'm going to do is I'm going to solder across there right now. I'm not great with the soldering iron, I always said that, but I'm actually getting better at it. And that's done. One extra thing you have to do on this board is you have to take a knife and you have to cut through the line at the very top here. If you follow this black line all the way up and just slice through the end bit here. Now it's difficult to see whether you've been successful really. So what I do is I just try and make a deep score in this area. And then you can check it with a voltmeter. And that's the voltage board done. So with regard to the NMEA219 board, I've got a new board here, and we're going to do all the preps we need to do on this one. Now this one's a little bit different than the previous one. For the battery monitor, we need to remove this shunt R100. We don't need that because we've got a bigger shunt for our battery, so that's got to come off. The other thing we're going to add to this is a capacitor, and the capacitor is going to go across these two pads right here, and then these resistors, and these resistors are going to be added to this wire and then basically go to the V in and V out, and that will be the circuit that provides us with filtering. So the first thing I'm going to do is I'm going to prepare this wire. So I'm going to start off by opening this up a little bit, and then I'm going to make this open the wires, get the wires stripped and ready. So then I'm going to basically connect one of these to the wire. So I'm going to turn these around and put them together like so. And then I'm going to continue that down the wire just for strength really. So it's going to go around the wire like this, just to provide a bit of strength so it's gripping the wire itself. Then we're going to do the same on the opposite one. So now I'm going to solder these. Okay, so with them soldered in place like so, I'm then gonna take a look here and make a piece of insulation and measure the insulation, go to about there. It will shrink a little bit when we put this on. Just going to go over there and then get another piece, and it's going to go to about there, and like so. Just going to put it here until it, make sure it covers everything. So that's probably enough. While these cool, we're going to start our work on the board. So the first thing I'm going to do is I'm just going to try and break the resistor. It sounded like it did. These are pretty much ceramic capacitors, so see that? It did. It broke in half, so it just came off. So if you do it right, it'll just pop right off, and then you can just move it to the side and get rid of it. You're not going to use that. So there you go. So what we're going to do is we're going to thread this through here like so. And get that down as low as we can. And then we're also going to do the same thing with these wires. Now these wires are going to go to the VIN minus and VIN plus. And make a note of which one you're going to put. Get my soldering iron, push it into place. Get some heat in. Oops. Just make sure you don't cross any of these. And then obviously be careful of the other 4 holes, because those are the 4 holes are going to be where you're going to solder it onto the main board that it's going to go on. Then again with the capacitor, and there you go, that's done. We're going to cut off these leads, so 1, 2, 3, 4. And that's, so I'm going to do a second one, and that's so I can show you the addressing. Here there is the address pads, and what we'll do on this one is just connect up AO and A1. Now this was a little tricky. I tried to do this yesterday on another one, but actually it was buried a little bit, but I tried to do it. So just be careful and make sure you connect in only AO and A1. Like so. So now you can see AO and A1 are connected together. So this is the Proto board that I'm going to use, and there's a lot of connections needed on this board. So rather than bore you with me soldering everything onto this board, what I'm going to do is I'm going to walk you through it on the laptop. So on the laptop here you can see the ESP32 pins. There's 2 sets, one this side, one the other side. One's longer than the other, so just bear that in mind and make sure you've got enough room to put these in. Also, there is a 4-pin header that I connected through here, which is for the power board. At this point I didn't connect the power board on, but later I will do. There is also here a piece that is just behind the board and will stop the board from grounding and touching the prototype board. I connected this connection here from the second one in on the power board here to the VCC pin on the ESP32, and that's the 5V from the power board. I also connected this line here, which is from the ground line of the power board into the ground rail Here we've also got 2 ground pins which I use to connect in the battery. I also have this pin here and I put a 2-pin header. It's very difficult to solder in a single pin header, so what I tend to do is I tend to put 2 pins. I don't really need these 2 ground pins, I only need 1, and I don't need these 2 12-volt power pins. I only need 1, but I've put 2 in because it's just easier to do. Between the 2 halves of the prototype board, they're not connected in as standard. You can connect them by putting this this pin across. So I've done that, and on the opposite side it's the same again, but with the for the positive loop. This positive loop is 3.3 volts, and the way it becomes 3.3 volts is through this line here. So this line here is from the ESP32's 3.3 volt regulator into the rail. Additionally, I looped in the ground line here to ground the ESP32. On this side of the board, I added a resistor between the positive line, so between the 3.3 volts pin 25, and that's the one-wire connection. I also at the same time I pulled out that line and pulled it out to the side here so that we could actually connect in all the one-wire stuff. So what I did after that is I basically added these extra I/O connections. So these are digital inputs that I've added for other things that I might need to use. I do have 5 of these earmarked for use with the black water tank level sensor, and those will be a little different, and I'll come back to that in a different video of how I'm setting that up. In addition to the digital pins, you also need power and ground for most things, so I've added more power and ground. These pins here, 14 to 17, are set aside for the I2C connection. Now, as you can see, I haven't put anything in there, and that's because the boards that are going to go on there are going to be mounted on the other side. You'll see that when the finished board is reviewed. And then this connection here is for the CAN board, and now that only applies to Nautical Sun's battery monitor, not to Appraise. And it will share 2 of the digital I/O pins and then 2 other pins, and those 2 pins will be defined as power and ground. So I'll pull power and ground from the rail here to power the board. So basically there's 2 different models that I've put together, one for my boat and one for Phil's boat, Nautical Sun. So this is what I've put together for my boat. I've already walked through the various bits and pieces on here. You've seen some additions. I added some of these terminals blocks so that I could put some one-wire sensors in and also some power in. And then on the front here, I basically used some buzz bar wire to connect straight through and into the 4 pins that are on the board where the I2C is. So there's 4 of them, you notice. 3 of them are for the batteries, my 3 batteries, and the 4th one is going to be used for a sensor. So it's going to actually just tap into the fuel sensor and see if we can pick up the fuel level based on that. This one is Nautical Sun's, so you can see it's very similar on the top. It's got the same power supply, it's got the same Firebeetle, it's got the same one-wire connections, and then on the other side here, it's only got 2 battery monitors because Nautical Sun only has 2 batteries, and it's got a CAN device. So this is the CAN board here. It's connected through the board directly, so it picks up 2 of the connectors, or 2 of the digital inputs on the board, and also power and ground. And you can see there's 2 lines going underneath over here, and those are power and ground to the correct spots on the board. So that's Nautical Sun. So we're going to look at the NMEA2000 integration. I'm not going to do a demo right here on the desk because the Raspberry Pi is over the other side of the room, and the ESP32 has to be connected directly to it because of the CAN messages. But I am going to walk you through it on the laptop. So firstly, here's the software. So starting at the very top, firstly, you have to define CAN pin numbers. So these are basically whichever pins you have connected to the CAN transceiver. Then we're just going to go through some of the basic stuff. You do have to define some some variables. So you define all your variables up here. I built this example from a variety of examples from Matty Sailorhat's code and also from Timo's work to define some of the libraries for NMEA2000, and I thank those guys for the work they've done so far. So I've defined it as battery A and battery B. There's two different batteries on this one. This one's just for Nautical Sun. So you'll see here, firstly, it calls out, is it time? Basically, is it time to send the messaging? So I'm going to go back and define where that comes from. So further back up, we set up these sets of messages, tiny scheduler, and then basically battery scheduler. And there's a schedule here for each of the messages. And you'll see that this says every 1.5 seconds send a message with an offset of 500 milliseconds. So half a second offset. And then the next message is 10 milliseconds after, the next message is 10 milliseconds after that. And then this B battery is half a second offset from that one, and so on. Once you've defined the schedule here, then this function here defines when the next time is and writes that in. And then the function that we define here to send off the messages comes from there. So it basically says, is it time? And then update the next time. So then there is these shortcut set NMEA2000 DC battery status. Now, instead of calling out the PGN numbers, which you can do, the team have basically defined messages in easier to read formats. So this one is define DC battery status, the next one define DC status, and the next one battery config. And then there's a load of variables based on that, and you can put calculations in there as well. I think there is a better method to define the state of charge, and actually I think I'm going to get some help from a guy, Chad, who might be able to help. Before you get to this stage, before you start defining all this stuff, you will have to define the special sensors that are going to be used in your NMEA2000. Here you go, you have to use this Lambda consumer, and this really took me a while to get this to work and also to understand what was going on. But basically, it really just transfers some of the variables so that they're usable, and that all that stuff is under the void setup. So you can walk through this and take a look at the messaging, but the code is already there and it's working. If anybody knows how to directly call out a variable and set the value for that variable in the app, let me know, because I've been struggling with that, and I want to do that with the shunt values so that those can be set in the app. What I've done here for the battery capacity, what I've done is I've pulled it into this linear calculation, but it shows up as a multiple. So it's a bit clumsy. If you look at the app, and I think I've got the app in the background, you see the capacity here, it says multiplier 90. That's because the capacity is 90 amp hours for that battery. And I set the value to 1 by basically doing a calculation where it was where I put one thing over itself to define 1, which is a bit of a long way around, a bit messy, but it works. Eventually, because this is going on a boat that does not have a Signal K server, I will set it up with its own access point versus right now it's set up to join the network. But right now in my Signal K, what you'll see is a load of CAN messages, battery 0 and battery 1, but then also the Signal K stuff for batteries A and B. And I did that so that I could understand which one was which. What you can do is you can filter. If you search and type in CAN, you'll just get the CAN messages. So what we got here is it's CAN 0, device 15, and then 127506 is the message, 127508 for that one. And then at the bottom here, you'll see 130312, and 130312 is the outside temperature, environmental outside temperature. If you do want to look at what traffic is being received by the Raspberry Pi, if you go in a terminal window, you basically put in CAN dump to analyzer and then analyzer. I'll post this, I'll put this in the description. It's definitely helped me debug. Now I can fire this off and watch the CAN messages come in real language. So that's the CAN stuff integrated. Try it out in a few weeks' time on Nautical Sun. You do have to be careful about that CAN device. It's got It's got a resistor on board, so it's got the terminating resistor that are built into the backbone on most boats. So you can either take that off and go straight into the end where that usually sits, or you can take the resistor off the board. Hopefully you enjoyed the video and found it informational. I did just get a comment in the Open Plotter forum, and somebody asked last week in the last video, why did I have the shunt on the positive side and not the negative side? Now the NMEA2000 board is a high side voltage and current sensor. So it's designed to go on the high side, not designed to go on the low side. And because it's good to over 26 volts, it allows you to be able to do that with basically only 2 wires. You do have to make sure that the negatives are tied together. So if you're testing and you're using your laptop to power the device, or you're using another USB port to power the device, make sure you tie in the negative line. If you don't, it will give you funny results. Hopefully you enjoyed the video. Give me a thumbs up, give me some likes, give me subscribe, write some comments. Let me know if you can help with any of the bits that we're struggling with. Thanks again. Bye.